My name is Forough Hashemi. I was the department chair for electrical department at Laney College. My background is electrical. I'm an electrical engineer. Before I came to Laney College, I worked in the field of spectroscopy, semiconductors, and solar industry. So when I was working at a solar company, I did a few trainings for the employees, and a few said, "Well, Forough, you're a great teacher. You should be teaching." And I thought, I never thought of that, but okay. So as I was working at the solar company, I came to Laney, to electrical department, and I started teaching actually the solar class. At the time, the department had a few standalone courses, electrical courses, which was great, but it wasn't enough for what the industry needed at that time, for the students to get ramped up and get in the field to get real jobs and have a real career. When I was teaching that one solar class, I noticed that we need way more to improve our students' knowledge. So I scoured around, I did some research, and since the department was an electrical department, I decided to develop some electrical programs, certificates, knowing that there will be a need for also electronics programs. But I left that for next. So the most popular program I could bring to the department was the electrician trainee program. In California, technicians have to be electrical technicians, as we call them, electricians, have to be licensed by the state of California. And there's only one way, and that is when students go to the unions, which is very difficult because unions have thousands of applicants every year, and they can only take, I don't know, 15, 20. So that's a tough road. And the next option would be for schools that have an approved curriculum, and they can train technicians, electricians for the state. So I developed a curriculum. There are about 11 courses in that program. I called it Electrical Technology Certificate. It was a certificate program. So we took it to the state. They came to our department, inspected our labs, our curriculum, looked at all our files, what we teach, what we do, and they gave us an appointment to go to the state in Sacramento, to the state office, and explain the program to all the attendees over there. And so my co-chair, Steve Weldon, and myself, we went there, and we explained what our goals were, what we wanted to do, and they approved our program. So school number 172 on the state's data website is Laney College Electrical Department. That included electrical courses, but I also looked around and what industries needed and how the world of electrical was changing. Suddenly we were making electricity with solar cells, with solar modules. Solar technology is an electrical technology. I brought that course also into the program. Our buildings were having automation for lighting, for HVAC, heating systems, air conditioning systems. We were moving towards electronics, and I had to get the students ready for that. I developed the lighting course and an advanced lighting controls. As the students were learning about electrical, they also had some introduction to electronics. So electrical technology had electrical courses, AC, DC, basic electricity, code, safety, and all that. And I added lighting and solar to it as well. So it was a full-blown program for electrical technicians. I think one of the reasons our program was very successful, we didn't show students just what to do. It was project-based. They had to build things, test things, but they also had to understand why. How do things work? When something goes wrong, when something breaks, how did it work in the first place? Education is very important in electrical, and the traditional electricians lack that because unions don't educate, they just train. They show candidates what to do. But I always heard that troubleshooting is what they want. The industry wanted troubleshooters. And it was hard for people in the field because they never understood how the systems work in the first place. So we educated. We taught them the math, the trigonometry, basic concept of electricity. So when they graduated from the program, they have a full knowledge of concepts, how things work, and how to install them. We offered different classes in basic electricity. For example, they built circuits. They built circuits and installed flashing lights for their bicycles. They used solar system on their motorcycles. They installed the inverter, the batteries, so they learned a lot about all that stuff. We made things not work. And motors, we actually hitched up 3-phase motors because we also teach 3-phase in the program in basic class. They made their own motors, DC motors, in classroom. So they got a good practice of putting the concept into actually something that works. We also had a summer bike program, also project-based. That was really one of the bright moments in my career here at Laney. I was meeting with a person in industry who was the owner of motors, speed motors in Alameda. And we were talking about having a competition on the Lake Merritt on the boats because he worked with boats. As we were talking, I said, how about bicycles? Can you help us? Can you give us some motors, some batteries? Why don't we just motorize the regular bicycles? He went through thinking, he said, yeah, I have the motors, I have the hub motors, we have the batteries, we can do that. And that's when the pathway, that was the first year pathway was just being launched, and we were getting some pathway funds. And I said, I think I can get something. I said, I've got a pathway project. There was no time to write a full program on it, but the concepts were all covered in basic electricity, EET 203, which is a course is already approved by the state. I used that as a shell. So students came in, we taught them the electrical concept, and we tricked them into learning by telling them, then you can motorize your bike last couple of weeks of semester and start riding. And that's exactly what we did. It became popular with parents, school staffs, children, young kids. We had students from all over. They had a lot of fun. And they learned to troubleshoot.
How do you bring in sustainability concepts and energy efficiency into the program?
As I said, everything changed on us. Suddenly with LED lighting systems were not the same. Now we had digital lighting, our heating, air conditioning systems. It wasn't just turn the switch on. Everything was being automated. And of course, state of California launching Title 24, which speaks to building efficiencies, and buildings have lighting systems, HVAC systems, and they all had to be automated because that was the code, that was the requirement. All the new buildings have to have automated systems. That means we don't turn the switches on, off anymore. And automation does that. So that had to be part of our program. Without that, we couldn't teach the program. So I went to a lot of industry meetings, and I knew what the need was. That's what they asked for, and that's when we launched advanced lighting controls that taught how to actually manage lighting systems without us touching the switches. Lights go on when people go to the offices, go off at the end of the day, and everything else as Title 24 requires, which is a code. they had to do if they wanted to work in the lighting industry. And of course, the same thing with other systems in the building, the heating system, air conditioning systems, they all had to be sustainable. So energy efficiency, electrical energy efficiency speaks to electrical energy. They can't not coexist. So yes, efficiency is directly tied to our program and electrical systems. We went from incandescent Edison light bulb, from an analog light bulb, to a whole different species of lights, semiconducting lights, LEDs. Now we could do so many things. There was no longer just put the switch, screw in the light bulb. And the students had to understand that, so we could control those lights. We can put them into advanced lighting controls. And coming from semiconducting background, and that's what the lights are, semiconductors. I jumped in, I studied more. I went to Davis, I think, UC Davis Laboratory. They were doing a lot of research on lighting. I worked with them a little bit. And I decided, yes, to launch that. As I said, it was part of the electrical technology certificate. But then I had to bring it up another step to advanced lighting, which was controls. And that's exactly what we did. So now we have lighting and advanced lighting controls. Because Title 24 required commercial buildings all have to have automated lighting systems, they required that these lighting systems to be inspected. And of course, whom they went to? Electricians, right? They're the ones who installed those lights. But those electricians did not have really automation, electronics background too much. I went to myself to CalCTP, which was an agency of the state, to train these lighting inspectors. And all the trainers had to be certified. So I went to their program. It was about a week or 10 days. I was certified as a trainer. So I taught the electricians who were in the field and had to inspect the systems and pass or fail the system. So I would do a 2-week course. They had to do a prerequisite, which is learning about lighting itself. And then we taught them about the test. How do they do the test? How do they pass it? How do they fail it? What is the state requiring? And there were 5 different areas they had to test for. And I taught that actually for a couple of years. But then I stopped about 2 years ago. But yes, we had electricians coming here. And I didn't certify them, I trained them, gave them the exam that was issued by CalCTP, California Advanced Lighting Control Training Programs. When they passed, I signed their certificate and mailed it to them.
So that evolution from incandescent lights to what we have now, both a new form of lighting and the automation of lighting, how much more efficient is that compared to the old incandescent light? It seems like it's a quantum advance almost.
It really is. If you compare bulb to bulb, incandescent, 100 watts, same amount of lumen or light, LED, 9 watts. So that's the watt hour. That's energy, of course. That's a pretty more straightforward math. But of course, these light bulbs have to go to a system, become automated, and those systems don't work free. They're all low voltage devices. They don't use a lot of electricity. But if you and I are not going to switch the light, if we're going to rely on the sensors need electricity. On the surface, there is a lot. There's really a lot of, yes, efficiency. But we're benchmarking the results, and we will have more benchmarking because it's very new. And this is across the board on the AC systems, heating systems, lighting system, all the automated systems in the building. So we are benchmarking, but definitely watt hour to watt hour, there's a big change, a lot of improvement. Automation, sensors are one way. Occupancy sensors are spaces that people come and go, bathrooms, hallways, and they go off. But where we have predictable occupancy, like if all come to this office 9 in the morning and leave at 5, The building manager will schedule on an electronics timer the lights to come on at, I don't know, 8:45 and go off at 5:15. It's automated. There's no sensor. There's no on and off. So that's programming into the timers. But as far as sensors, we have occupancy sensors, which reacts to occupants, and we also have the latest and newest is the photo sensors, which for daylight savings, if there's sun out and you have good windows with bright light, that sensor will sense the photon and dim the indoor lightings down to 60%, which is what the code requires, 60% reduction.
Mm.
Yeah.
Can you talk about you work at Laney, and what is the service area for Laney? Where do the students come from, and do you have any challenges teaching this advanced subject? Do they have academic challenges and so forth, and how do you address those with the program?
The electrical technology certificate, which was approved by the state, that I think we're still one of the very few colleges around the Bay Area. So we had students coming from north of the Bay, Petaluma, Santa Rosa, San Jose, through the tunnel, Moraga, Walnut Creek, San Francisco. So we're really electrical trainee program attracts students from everywhere because the program built a good reputation. And of course, they have to take an exam with the state to pass that exam. And then once their hours are completed, the state will grant them a license. We don't license the electricians, the state does, but we teach them how to acquire that license. So that's as far as that part. And then with these other electronics, as we brought in more, which, as I said earlier, I started developing electronics program, advanced lighting programs, PLCs. So these are the courses that teaches the students a little bit more about electronics and programming. So, and it ties right into controls. And that's how we tied the gap. And I was working closely with the industries to make sure that I know what they're looking for, and I brought it directly to my program. We had semiconductors and programming, electronics 1 and electronics 2. I rewrote those programs, and we brought Raspberry Pi programming into those two courses. I was just slowly moving students into understanding the programming more. But as always, finding instructors to teach those courses was the biggest challenge that I faced here at Laney. The program is open enrollment, which means we don't do a lot of vigorous entry testing to do placements. But my first introduction course with students was always this. You're going to need the math, you're going to need the trig, you're going to need the basics. And if you're good for it, I can teach you all of that. So you don't have to take 2 semesters or 3 years to do math or to do this and that, electrical. I teach you right here, but you have to be present in classes. You can't have one absent. And I'll come around, I'll show you how to use your calculator, and which is what I did. Yes, it was very challenging. And of course, we had some students who didn't speak the language, a bit of language barrier. And I always encourage those students to work with other students or come and see me, ask me questions. And I also encourage them to take some English classes because college offers all those courses. I don't know, miraculously, I was able to actually bring all those students along and have them to complete the certificate program because they did exactly, 90% of them did, as I said. Attendance rate, the night before Thanksgiving, I had 100% attendance in my solar class one night. I told my family, oh, nobody's going to show up. I'm going to go to class and just leave. I entered the class. All 55 students were sitting there. Brings tears to my eyes. The faith they had in me and my program was amazing. So they appreciate that I'm there to coach them. And they just took every bit of it. And they overcame the challenges. To become a licensed electrician, you need the certificate, you need to pass the state exam, 3 requirements. And the third one is you need to complete 8,000 hours of electrical work in the field. And our program was the full, what they call journeyman program. It wasn't the residential, it was commercial and full journeyman. So they needed 8,000 hours. And the exam that they take with the state is also the big exam for the journeyman. And yes, they had to work during the day to make those hours. But once they come to our program, I signed a letter for them, sent to the state, they sent it, that they are a trainee. State calls them trainees. And then trainees can get electrical jobs easier. So they would get the trainee cards, and I had some contacts with some small electrical shops. They would call or email me, say, Forough, we need a couple of good students. I would recommend good students. And also, big companies were hiring actually trainees. They would contact me, say, Forough, we want to come to your department, recruit some trainees. So we definitely help the students to get in the field as they are working towards their certificate, also make their hours. So a lot of students, by the time they graduated, they probably had already 3,000, 4,000. And we also had some electricians who were in the field. They were already licensed, but they didn't understand the electronics, the programming, and they wanted to move on and make more money, but they had no certificate or no degrees. The union, I used to tell the students, the unions, you all love to get to unions, but unions doesn't give the students certificate or degrees. We do. We're a college. They're not. They give certificate of completion, but our certificates are transferable. And so I told them this is a better way to become an electrician because now you also have that degree. So I would ask the students who came from the field to speak to the class, let them know how that has been an obstacle for them. Without a certificate, even though they are a licensed electrician, they can't do a whole lot because they don't have the degree. So we're actually better on both sides. Well, like every other field, it has to do with, of course, experience, but trainees can make up to $20, $21 an hour, trainees, while they're training, and coming out 60,000 once they pass the state exam and they have their hours. And they can also go to business for themselves, electricians. And electricians, they can hire them to change your service panel. They can charge $5,000 to $10,000 just to do that. So if they're experienced, as I tell the students, it's a career. It's not just a job. That's why I developed certificate programs, not just standalone courses, because I knew with 1 or 2 courses, they couldn't be good enough to stay in the field and become electricians. The certificate gave them a great rounded education. And it's a career. They decide, yeah, work for PG&E once they're more experienced, other big electrical companies, they can be in business for themselves. Yeah, so there were a lot of opportunities, but good salaries.
What about going into the solar industry? Does that pay as well as some of the other aspects of the industry?
Solar is still, I think, growing, but from the time I started teaching solar, from 175 watts, which was the latest and the greatest modules that we had, we're at about 450 watts. And there's a lot of installations. Seems like the government, the states are getting more involved to move that industry. Still really needs a lot of growth, but solar is a big part of electrical. To install solar systems, you have to understand electrical concepts. A lot of people have solar. When you ask them what size is your system, they don't know. Average consumer doesn't know. But those people who install them, they have to understand the electrical value of that module. The modules are nothing more than electrical systems. They give us electricity, right? So if we don't know what electricity is, how it works, they're just some modules. So yes, solar was a big part of electrical. That's why I included that in our certificate. So when our students graduate, they can choose to go to solar industry. Solar, photovoltaic, that's what we taught. We didn't get to hydro, but yeah, solar photovoltaic was part of our program. When a new technology comes in, we think that automatically everything old disappears and we can replace it with new stuff. So that's the discussion I had with students. People thought we could all install solar system and life is great. We really couldn't, because our utility companies or that analog grid did not have the infrastructure for this electrical feeder coming into it, right? It's like a road with 2 lanes, only so many cars can travel. Yes, we were all anxious to go, but we had to wait. So PG&E had to build transformers, conductors, because we all send this electricity to the grid. The size of the wires were the size that they were sending electricity to. Now suddenly we all want to do the same thing. So permits were delayed, installations were delayed, and this system also have to be tested. Just because the technology is there and work in the lab, it doesn't mean that we can roll it out and it'll be perfect. So it has to be installed slowly, tested, observed, and then we build more infrastructure for it and more. And I don't know, 10 years from now, just like the electrical cars, we don't have enough charging stations for all electrical cars, right? Even if Tesla makes 500,000 cars a day, where are they going to go? Where do we plug into? So trend is that I think in the next 10 years, buildings as we know them, cars, our lighting systems, it's going to change. They're not going to be there as we know them today. But it takes time, yeah, for that development. The jobs are there. I told the students, the lighting industry is a whole new industry. There was no light. When I started teaching lighting, there was no book, no textbook. All residentials used 1 incandescent light bulb. Commercials were 4100 Kelvin T8s, which I still left back there for show and tell. But that's all it was. But today they're all tied together, and electricians have to have the knowledge of automation, how this digital light works, how the heating systems in the building and AC systems can be programmed. And that's when I started developing the electronics part of this industry. So our students will have both. But today, electricians in the field, when I was teaching those Cal CTP people, electricians in the field, 30 years, they had no idea how this, they would get mad. That's not how we do things. I've done it for 30 years that way. They really had the hard time to understand things have changed. So I would say the biggest challenge for the technicians, electricians, is really education. With educating these people, we're not doing things the same way. Yes, it worked for 30 years, but I'm sorry, we're taking those things out. We're installing new things, and that's how they're installed, that's how they work. They need a little programming. So yeah, the biggest challenge I had in that Cal CTP training group, they really had a hard time understand why do they have to do things so differently. So yes, education is a big part of for everybody. Our electricians in the field, they really have to ramp up to work with new devices. California actually has a shortage of electricians. That's why there are jobs and they get hired quickly and they get paid well. There are not enough electricians. There is a path to get there. And I used to tell the students, like a college degree. It takes 4 years to get a bachelor. So yes, you're going to have to invest 3 years, at least 3 to 4 years, to become a full licensed journeyman or electrician. The certificate time and field time. Our program here at Laney is really pretty full-blown at the moment. We've got good electronics program. They're all written. They've been approved by the state. Courses are there. And our electrical part also, we just need good instructors to come and teach those.